Alright class, welcome back. So this is going to be the video for 8.1, which is going to be working on different ways to solve quadratic equations. This specific video is going to be about using the square root property. Basically what the square root property says that if a squared equals b, then a is equal to the plus or minus square root of b. Of course, b has to be a real number. Okay, so what that means is if I have an equation, say that x squared equals 25. Again, we've done this before, solving these quadratic equations by setting them equal to 0, having like ax squared plus bx plus c and setting it equal to 0. That's great. So I can subtract the 25 from both sides and we'd get x squared minus 25 is equal to 0. And then I'd say, hey, this is a difference of squares. So perfect square, and a difference. So this would factor to a plus 5, x plus 5, x minus 5. So the question here then would be, well, then what would I substitute for x, excuse me, to make this factor 0? So my value here would be negative 5, and my value here would be 5. Okay, so then x is the value both 5 and negative 5, or negative 5 and 5. So you can see that if I had this and I just said, well, I'm just going to take the square root of anything squared is just that thing. So I'd get just x here, but this is going to give me a plus and a minus 5. So you can see the square root property verifies the factoring that we've done, and with a number that you can actually see as a perfect square, you can see why you would get a plus 5 and a minus 5, because both of those values would make the statement true. So that's why we need both the positive and the negative version. Okay, so this is the general square root property in its simplest form. I'm going to go through several other problems now, with problems that we previously tried to factor but we can't factor now. Or we previously tried to factor but they were not factorable. So for instance, if I had x squared is equal to 128 and we tried to factor this, we would say, well, this is a perfect square, but this, no bueno, right? Not a perfect square. So I'd just be like, well, that's prime, unfactorable, but using the square root property, I can just take the square root right away and factor this down to 64 times 2 and say then that x is equal to the positive and negative 8, because that's the square root of 64, times the square root of 2. Okay, so this tool, the square root property, gives us the opportunity to solve quadratic equations that we previously couldn't solve using factoring, which is why it's so great. So a couple things I want to note here is that a squared can be just a variable, like it can just be literally like x squared. It could be b squared. It could be any of these, but it could also be a two-term squared, a binomial squared. So it could be like x plus 2 squared, or it could be c minus 5 squared, or whatever the case is. It could be a two-term binomial that's being squared. So what we want to do here when we're using the square root property is our first step will be to isolate the radical. Again, back to our solving equations. Isolate just means I'm going to undo any addition or subtraction connected to that radical. So what do I mean by that? Well, if I had a x squared minus 3 and that was equal to 12, then I would want to get this 3 out of the way, away from the radical. So I would have x squared is equal to 15. Once you've isolated the radical, then you can take the square root. So here I just get that x is equal to the positive negative square root of 15. Okay, so that's isolating the radical. The second thing we want to do is we want the coefficient of the radical to be 1. This is the same thing we do when we're solving linear equations. We want it to be a positive, that's a 1, positive 1. That was an ugly one. Let me write that again. Positive 1. Okay, so well, what do we mean by that? Well, if we had a problem that looked like 7x squared is equal to 112, this is isolated. There's nothing connected to this x squared term through addition or subtraction, but I need to get this coefficient to be 1, and right now it's 7. The way we're going to do this is we're going to undo any multiplication or division that's connected to this variable. In this case, it's multiplication, so I'm going to do the opposite, which is divide both sides. So I'm going to get x squared is equal to 16. Now that I've got the coefficient to be 1, I can now take the square root because this is isolated and the coefficient is 1. And here we would get the x is plus or minus 4. Okay, but what if we have both the coefficient of the x squared term and something connected through addition and subtraction? Well, I'm just going to isolate it by subtracting the 2 from both sides. And I'm going to get the coefficient to be 1 by dividing both sides by negative 5. So you'll notice here, then now that I have the x squared, now that I have it in this format right here, then I can take the square root, and I'll get that x is equal to a positive and negative 3. So this is kind of the most difficult you could see with just an x squared term. Now I want to do a couple of these with a binomial squared. So if we had x plus 5 and that was squared and equal to 36. Well, I don't need to like add or subtract this because this is the entire squared term. It's a 2-term squared. So this is isolated. There's nothing on the outside connected through multiplication and nothing on the outside connected through addition or subtraction. So I can just take the square root right now. So then I'll get x plus 5 is going to be equal to plus or minus 6. These are two separate answers here. One of them is plus 6 and the other one is minus 6. I still have an isolated x. So if we have a 2-term squared, or a binomial, then you still need to isolate x or solve the resulting equation. And we're going to do that by basically repeating steps 1 and 2. So I'm going to isolate this variable again and say, okay, x is going to be equal to a negative 5 plus or minus 6. Again, it's important to note this is two separate answers here. One of them is the x is negative 5 plus 6, and the other one is x is negative 5 minus 6. So in this case, when I combine these, x is 1, and in this case, when I combine them, x is negative 11. So those are my two solutions right here. X is the value of negative 11, and x is the value of 1. You can plug those back in and see, verify that they work. So if we plug in 1, then we get 1 plus 5 squared is equal to 36 into the original equation. Well, 6 squared is 36, so this is true. The original equation also could have negative 11 plus 5 squared and say that that is equal to 36. Well, negative 6 squared is indeed equal to 36. So you can see how you can get the answers here. So let's do a couple more of these. And we'll do at least one that deals with I. Right now, let's try this one. This squared term again is already isolated. So I'm going to take the square root right away. I'm going to get x minus 3 is equal to 40. 40 is going to simplify to 4 and 10, which is going to give me a plus minus 2. This 4 comes out. Square root of 4 is 2, and the square root of 10 is going to stay under. Then I'm going to add 3 to both sides. So this is a positive 3 plus or minus 2 square roots of 10. Again, these are two separate answers here. X is equal to 3 plus 2 square roots of 10, and x is equal to 3 minus 2 square roots of 10. Okay, so that is one where this isn't a perfect square. We can see how it creates a two-term answer. This answer actually has a value. So these are considered exact answers. And exact means they're exactly that, they're precise. But you could, however, plug into your calculator the square root of 10 and say, well, let's approximate that. What does that equal? I don't have a calculator with me, but you could go through this exercise. We know that it's going to be really close to 3. It's going to be 3.1 something or 0 or something like that. Again, I'm not using calculator currently. So this value is about 3. So if I plugged it in here, I would say 3 plus 2 times 3, that would be 6. So 3 plus 6 would be 9. So this value here is approximately 9. The value here, again, this negative 2 times 3 would be negative 6, would be approximately negative 3. If you were going to approximate those answers. We'll do this more in future sections when it makes sense to do that. Okay, so a couple more just to make sure we've thoroughly covered all the things you might see or need to know for these sections. Again, this is isolated. There's nothing connected to the entire squared term through addition and subtraction on the outside or through multiplication. So I can just take the square root right away. And we would get then that 5x minus 2 is equal to plus or minus 3i. Remember that this factors out to 9, or the square root of 9, and the square root of negative 1. Square root of negative 1 is I, and the square root of 9 is 3. So that's where we get this plus minus I. So if what's under here is negative, then you're going to have a complex number. This was a binomial squared, so then I'm going to solve this resulting equation. So I have that 5x is equal to 2 plus or minus 3i. Still not sure what x is because I need to divide both sides by 5. And again, these are two separate answers, 2 minus 3i over 5 and 2 plus 3i over 5. Oh my goodness. Excuse me. Okay, so let's do one more. This will be the hardest one. We'll have to go through every single one of these steps here. So let's say that we have 3x plus 7 squared minus 27. Is equal to 135. Let's make this minus and this plus. Okay, so what we're going to do is I'm going to say, well, here's my squared term. So this is the thing I'm trying to isolate, but it's got this 2 connected to it through multiplication and this 27 connected through addition and subtraction. So my first step is I'm going to undo any addition or subtraction connected to the squared term. So I'm going to subtract 27. When I subtract 27, I get a negative 162. Now I'm going to get the coefficient to be 1. Right now the coefficient of this squared term, even though it's a binomial squared term, is 2. So I'm going to divide both sides by 2. And I'm going to get the 3x plus 7 squared is equal to a negative 81. Okay, now if it's a binomial squared, then we're going to solve the resulting equation, but I actually have to take the square root. So I'm going to take the square root here of both sides, and I'm going to get 3x plus 7 is equal to, again, this will factor to a negative square root. and a square root of -1 and a square root of 81. So this is going to be a plus or minus 9i. Now I still need to solve the rest of this by isolating the variable again. And by dividing both sides by 3. So we get then that x is going to be equal to -7 plus or minus 9i over 3. Now you could reduce just these two, but the answers will look like this. And again, this is two answers. It's -7 plus 9i over 3 and -7 minus 9i over 3. Okay, so this is a pretty thorough covering of the square root property.